Okay, so let's start with chapter 2, measurement experimental technique. We'll be doing chapter 2 today together with chapter 14 on metals. Okay, chapter 2 is a relatively short chapter. There are only a few main things that you need to take note of. Okay, so let's start now. Okay, so under chapter 2, I think for the first part in terms of measuring physical quantities, I'll just skim through this quickly because most of you are actually quite clear on what are the things already. So first thing, measuring mass. So do take note, SI unit for mass is actually in kilograms. Okay. What is used, okay, to measure mass is actually beam balance. But what we typically use in the lab is actually the electronic balance. So for pure chem, when especially you need to do planning experiments or when you need to prepare your practicals kind of thing. So do take note, you better know this thing here, electronic balance, because if you need to weigh anything, you will use your electronic balance. Okay. Next one. Okay, let's go on. Okay, sorry, one part here. Okay, for electronic balance, do take note of the accuracy of it. Okay, it's actually only plus minus 0.01 grams. Okay, so please don't go and different electronic balance. Actually, you will see that some of them actually have 3 decimal places instead of 2. But do take note, please only have it up to 2 decimal places. So this part, right, take note. Next one, measuring time. I think most of you are aware, time, SI unit is actually seconds. You will typically, in the lab, you have your digital stopwatch. Okay, now, the accuracy of a digital stopwatch is plus minus 0.01 second, but I think those of you who take physics, okay, you realize that your teachers tend to say that, no, okay, it shouldn't be this. Okay, actually it should be plus minus 0.1 seconds. Your accuracy, okay, that you write down in terms of recording, okay, should be to the nearest 0.1 second. This is for physics. Okay, however, in chemistry, we are not so particular in terms of the degree of in terms of how until 0.01 seconds are typically in chem, we'll just record it to the nearest seconds instead of like 1.05, 1.03, those kind of timing. Okay, so take note, there's actually a difference between what is recorded, what is seen here, and also what physics will actually tell you to record in your practicals. Okay, why is it so? For those of you who want to find out more, it's actually due to the human reaction time. Okay, so you can read up more in your chapter 1 in your physics under measurement. Okay, human reaction time level. So you can read up more. So that's for time wise. In terms of temperature, okay, I know many at times you always know that temperature is in degrees Celsius, but actually the SI unit is Kelvin. What we'll normally use in the lab itself is the alcohol thermometer, because mercury, we will try not to use it due to mercury is being toxic. Okay, so we will try not to use mercury thermometer in the lab itself. A data logger is another one that you can use, but we seldom use it in the lab per se, because it is not so easy to use. There's quite a bit of setup that's required. Okay, so this one, do take note. Okay, it is in your syllabus, okay, that you need to know that data logger exists. Okay, this exists. Okay, but okay, whenever you're planning experiment, my suggestion is go for the alcohol thermometer instead of using the data logger per se. Okay, let me stop my video. I so paiseh to keep letting you all look at me. Okay, next, let's carry on. In terms of measuring volume, okay, the SI unit is cubic meters. You will normally not measure in cubic meters. The one that you will typically use in the lab, the measurement will be in cm cube, okay, cubic centimeter. In terms of gas, when you do your calculations, it will be in cubic decimeter. Okay, please know the conversion, especially for this one over here. Okay, this is more used for your mole calculation. So take note of this. Okay. Now, in terms of measuring volumes, I think by now you should be quite familiar with everything already. Okay, the most common instrument that you use in the lab is actually this tree to measure volume. So I will not be going through too much of this in detail for now over here, okay, because this will be mainly covered in the lab itself. However, in terms of recording of decimal places, take note, burette, you realize it's always to 2 decimal place. In terms of pipette, we will typically have it in 1 decimal place. Okay, So this will be it for in terms of the measurement. Parallax error, all this I think shouldn't be too much of an issue. Now, I want to put a star over here, okay, because how to measure volume of gases. You subsequently in this chapter, there'll be a lot about collecting gas, how to dry the gas and stuff. So the subsequent chapters, a lot of it will be on gases. So how do we actually measure gas? Okay, measure the volume of gas. Key instrument we'll use is actually using a gas syringe. Okay, so to measure the volume of gas, we'll typically use a gas syringe. How much you can measure, take note the maximum volume is actually up to 100 cm cube. Okay, 100 cm cube. So how to draw it? Please know how to draw. So please know how to draw. Please know how to draw. When you're drawing it, please take note, you don't need to actually write down all these minor numbers over here. You just need to draw the gradations. That means all of these little lines over here. Or you don't need to write the 0, 10, 20 in your drawings. Just the markings will do. Okay, so that's for 2.1. Quite a breeze running through it because most of it you have covered in your Sec 1, Sec 2, lower Sec syllabus. Okay, I'll just touch on some of the main points. Now, 2.2 here, I want to highlight more in terms of the methods for collecting gas. Okay, do take note, there are three main methods for gas collection, three main methods. One is called the displacement of water method. The other one is called the downward delivery. In the downward delivery, okay, actually you are displacing air, just take note. Actually, this is actually a displacement of air when you are doing the downward delivery. Same thing, upward delivery, okay, it looks like this. This is also a displacement of air method. Okay, but the name we give displacement of water, downward delivery and upward delivery over here. So the key question is, when do we use downward and when do we use upward? When do we use displacement of water? Okay, first thing, displacement of water, we will normally use it to collect gases that are insoluble or slightly soluble in water. This is the key point of when you use displacement of water. In terms of downward displacement, okay, we will normally use it to collect gases that are soluble in water. So that's the first condition. Second condition is that it should be denser than air. Next, for upward delivery, okay, same thing, there's two conditions. First, normally we use it to collect gases that are soluble in water. Second condition, it should be less dense than air. So in terms of these three methods, you should be able to differentiate when to use what. So in the next page, what you're going to see is this table over here. So question is this, okay, some of you may ask, Che, must I use displacement of water for this tree? Okay, can I use other methods? Answer is yes. Now, why did they use the displacement of water? Because of its solubility in water. You realize all these gases are either not soluble or just slightly soluble in water. And hence, because they are not soluble in water, you can use displacement of water. However, can I use upward and then downward displacement? Answer is yes. Hydrogen being less dense than air, actually, I could also use the upward delivery method. Slightly denser, these two, I can actually use the downward delivery. Okay. So the displacement of water is one method, but must be flexible around it. Okay, knowing what's the difference between upward, downward, and displacement of water, you can actually vary it a bit more. Okay, depending on which property you're looking at, whether is it the solubility in water or whether is it the density compared to air. Now, the last part for this chapter is really about drying of gases. Okay, so when you want to collect the gas, sometimes water vapor is in it. So what you want to do is you want to get rid of the water vapor. So the question is, how can we get rid of it? There are three main methods. Either you use corn sulfuric acid. Please know how to draw it. Okay, please know how to draw it. We can either also use quicklime, which is also calcium oxide. So this quicklime over here, the drawing, please take note. And the last one, we can use fused calcium chloride. So, of course, the main question is, I got three methods. Which one should I use? Okay, for this quicklime, okay, do take note. This, I will put an exclamation mark. Typically, we'll use this to dry ammonia. So whenever they got a question asking you to have ammonia, and you need to dry it, okay, so you need to dry ammonia gas, what you should use is quicklime. Okay, consulfuric acid and fused calcium chloride cannot be used to dry ammonia. Why? Okay, so take note, ammonia will dissolve in the fused calcium chloride. Sorry, spelling error. Let me erase it. Okay, in the fused calcium chloride. Okay, in the midst of drying it. Because why? In the fused calcium chloride, actually, when the gas passes through it, okay, the water will actually form around the calcium chloride. So you will start to see water forming. And because ammonia is actually extremely soluble, so once there's a little bit of water there, the gas will actually dissolve, and hence you will actually reduce the amount of ammonia that's coming out of your fused calcium chloride. Secondly, why cannot use consulfuric acid? It's because ammonia is alkaline in nature. Okay, and you know consulfuric acid obviously is an acid, right? So the alkaline nature will react with the consulfuric acid. So because of all these conditions, that's why you realize ammonia should only be used with quicklime. It shouldn't be used with fused calcium chloride. It shouldn't be used with consulfuric acid. Now, then question is, so when should I use fused calcium chloride? When I should use consulfuric acid? Do take note, consulfuric acid can be used to dry most gases. Okay, so other than ammonia, actually most of the other things you can use consulfuric acid. Right, that's the main point I want to make across. So other than ammonia, actually most other gases you can actually use consulfuric acid. Okay, then you ask, can I use fused calcium chloride instead? Look at this here. Also can. So the only thing you must take note, the only gas you must take note is ammonia. Ammonia is the unique one that you must be careful. It should only be used, quicklime should only be used to dry it. Okay, so this is for chapter 2. Actually, we are done with it. So just to quickly summarize chapter 2, you realize the first main segment actually deals with your measurement of physical quantities. That's the first segment that we have gone through. Then the second part, actually, we are looking at how to collect the gas, okay, which then you will talk about these 3 methods. There's one part that's missing here that we have actually gone through. So this is the second thing that we went through. The third thing that actually went through was the drying of gas. Okay, so this chapter actually only has these 3 main segments within here. So if you are revising this will be quite a quick chapter to revise. Okay, but I want you to take note of point 2 and point 3. Please remember how to draw. Okay, because in terms of your planning of experiments, in terms of a theory paper, you realize that there are times where they will ask you how to go about drawing, okay, describing with the aid of a diagram how to go about doing certain experiments. So drawing is critical in this chapter. Okay, so that's for chapter 2. Okay, I'm going to stop recording now.